Welcome, fellow travelers of the cosmos. Today is June 4th, 2025, and we have some fascinating news. We live in a truly magnificent galaxy. We call it the Milky Way. This is our home, our cosmic city. It's a vast, swirling collection of billions upon billions of stars. Our own sun, the star that gives us life, is just one of them. A rather ordinary star, nestled in a spiral arm somewhat on the outskirts of this grand structure. We are, in a very real sense, stardust, animated by the universe, now looking up and contemplating the stars themselves. Imagine the sheer scale of it all. Now I want you to look out into the deep, dark night sky with your mind's eye. Far beyond the familiar constellations that our ancestors charted. On a perfectly clear night far away from the glare of city lights, you might just spot it. A faint, fuzzy patch of ethereal light. That, my friends, is the Andromeda Galaxy. It is our nearest large galactic neighbor, a true titan of space, another majestic island universe. Andromeda is even bigger than our Milky Way, a breathtaking spiral, much like our own. It's another city of stars, brimming with its own hundreds of billions of suns, out there in the cold, dark, and vast expanse of intergalactic space. For many, many years, astronomers have told a dramatic and compelling story. It was a story of cosmic destiny, writ large across the fabric of space-time. The Milky Way and Andromeda, these two colossal galaxies, were not just idly drifting apart. No, the narrative was that they were on an unavoidable collision course, hurtling towards each other at incredible, almost unimaginable speeds. We're talking about millions of kilometers every single hour, a relentless cosmic approach. An inevitable, spectacular crash was predicted by our best models. A cosmic merger of truly unimaginable scale set to occur billions of years into our distant future. This predicted future event, this galactic pileup of epic proportions, wasn't something for us, humanity, to fear directly in our daily lives. The timescale involved is simply immense, stretching into an abyss of time so deep, it's hard to fully grasp. It's far, far beyond our individual lifetimes or even the conceivable lifespan of entire civilizations as we know them. But it was, and it remains, a profoundly fascinating prediction about the universe we inhabit. It spoke volumes about the dynamic, ever-changing nature of the cosmos itself. Galaxies, you see, don't just hang motionless in the void. They move, they interact, they merge, they evolve. We thought we clearly understood our galaxy's ultimate fate. But science, as I always love to say, is a journey, not a final destination. It's a continuous process of discovery, of questioning, and of meticulous refinement. Our understanding of the universe is always being updated, always evolving. New evidence emerges from the darkness, new technologies grant us sharper, more insightful views of the cosmos. Recently, brilliant scientists harnessing the immense power of modern supercomputers have unveiled new, highly detailed simulations. These aren't just simple back-of-the-envelope calculations, they are powerful digital laboratories. They model the complex gravitational interactions of galaxies with incredible, breathtaking detail, incorporating all the latest observational data we have gathered. And guess what? These latest, most sophisticated simulations are painting a rather different and quite intriguing picture. A surprising twist in our cosmic tale, a new potential chapter in the grand galactic saga. They suggest that the Milky Way and Andromeda might not collide head-on, as was widely and previously thought. Instead, these two galactic behemoths could engage in an elaborate, almost graceful cosmic dance. A close pass, a profound gravitational embrace, perhaps even a near miss. Imagine that for a moment, two giants, each containing hundreds of billions of stars, waltzing through the vastness of intergalactic space, their fates intertwined but perhaps not immediately merged. Picture it in your mind's eye, two colossal dancers, each stretching hundreds of thousands of light-years across, gliding past each other in the cosmic ballroom. They wouldn't necessarily smash directly into one another, but their immense gravitational fields would still profoundly interact. They would tug and pull at each other with unimaginable force, a silent, powerful conversation across the void. Stars could be ripped from their galactic homes, flung out like cosmic confetti into the lonely, cold void of intergalactic space. Great clouds of interstellar gas and dust could be compressed and shocked, igniting furious bursts of new starbirth. A different kind of cosmic spectacle, to be sure, but spectacular nonetheless. This new, evolving understanding comes from better, more precise data than we have ever had before. We now have more accurate measurements of the galaxy's velocities as they move through space. We have a much better handle on their trajectories, their precise paths through the vastness of the cosmos, and crucially, we are learning more and more about the pervasive influence of something vast, unseen, and deeply mysterious dark matter. This enigmatic, invisible substance makes up the vast majority of mass in the universe, far outweighing all the stars and gas we can see. Its gravity is the hidden hand, the unseen choreographer that sculpts the dance of galaxies, and we are only just beginning to unravel its profound secrets. So, you might naturally ask, why is this potential change from a direct collision to a near miss so incredibly important? Why does it capture the imagination of scientists and space enthusiasts alike? Well, quite simply, it's exciting. It beautifully showcases the very essence, the beating heart, of the scientific process itself. We observe the universe around us with our instruments and our intellect. We formulate hypotheses, which are essentially educated guesses, based on what we see and what we know. Then, we test those ideas rigorously, relentlessly. We gather more data, we refine our models, we challenge our assumptions. Our understanding of the cosmos is always evolving, always growing. This is how we learn. This is how we make progress. A near-miss scenario instead of a full and messy merger opens up a whole new universe of fascinating questions for astronomers to explore. What truly happens on a galactic scale when two giant galaxies experience such a close encounter without fully combining right away? How are their delicate spiral structures, their arms full of stars and nebulae, warped and reshaped by the powerful gravitational tides they exert on each other? How does such an event affect their long-term evolution over the subsequent billions of years? It provides us with a different kind of cosmic laboratory, a new and intricate puzzle to piece together, offering fresh, invaluable insights into the complex world of galactic dynamics. This development also serves as a powerful, and I think humbling reminder for all of us. The universe is wonderfully, mind-bogglingly complex, far more intricate than our simplest models might suggest. Our scientific models, while incredibly useful and often remarkably predictive, are ultimately approximations of an even richer, deeper reality. The cosmos always has more surprises in store for us, more wonders to reveal, more mysteries to challenge our intellect. That for me is the sheer beauty and the unending thrill of scientific exploration. There's always something new to discover, something just beyond the current horizon of our knowledge, patiently waiting to be understood by curious minds. Understanding these grand galactic interactions, whether they turn out to be direct collisions, gentle mergers, or dramatic near-misses, is absolutely key to our broader understanding. It helps us piece together the epic, sprawling history of the universe itself, from the fiery crucible of the Big Bang to the vast, structured cosmos we observe today. How did galaxies like our own Milky Way, these magnificent cities of stars, form in the chaotic aftermath of cosmic dawn? How did they grow to become the magnificent, sprawling structures we observe today, filled with such diversity? These events, these powerful gravitational ballets played out on the grandest of scales, shaped the large-scale structure of the cosmos, the intricate cosmic web. Every new piece of information is vital to completing that cosmic picture. What does this new perspective, this potential adjustment to our cosmic forecast, mean for the future of astronomy and for our ongoing quest to understand the heavens above? It means, quite clearly, that we need even more observations, more high-quality data. We need more eyes on the sky, more powerful telescopes scanning the depths of space with ever-increasing sensitivity and resolution. Instruments like the incredible James Webb Space Telescope are absolutely crucial in this endeavor. It can peer further back in time and with greater clarity than humanity has ever managed before. It can study the faint extended outskirts of galaxies, looking for the telltale signs of past interactions, the faint whispers of ancient gravitational dances. We must keep looking. We must keep questioning. This discovery, this potential rewriting of a long-held galactic fate, also subtly tweaks the long-term forecast for our own cosmic home, the beautiful Milky Way. Its ultimate destiny, billions upon billions of years from now, is still being unveiled, still being gradually written in the stars and in the data we collect. Will it eventually merge with Andromeda after a series of close passes, a prolonged courtship before the final union? Or will it navigate a different path through the cosmic ocean, perhaps having more of these dramatic cosmic near-misses with other galaxies in our local group? The story of our galactic home is an ongoing saga, a cosmic epic, and we are incredibly privileged to be able to decipher parts of its unfolding narrative. But please remember, this news, this unfolding cosmic drama, isn't just for astronomers in their lonely mountaintop observatories or for physicists scribbling equations on blackboards. It's for everyone. It's for you. It's for me. We are all inhabitants of this grand, astonishing, and often perplexing cosmos. Learning about its intricate workings, its deep past, its potential future, expands our horizons immeasurably. It ignites our innate human curiosity. It fuels our profound sense of wonder. It connects us in a very tangible way to something truly immense, ancient, and deeply profound. It gives us invaluable perspective on our own existence here on this small blue planet. So I ask you directly, what are your thoughts on this cosmic revelation, this potential plot twist in the Andromeda story that has been developing? Does the idea of a galactic near miss, a close brush with another giant galaxy, intrigue you more than the prospect of a direct galaxy-shattering collision? Or perhaps you find the collision scenario more compelling? We genuinely invite you to share your opinions, your feelings, your cosmic musings in the comments section below. Let's discuss this amazing, ever-surprising universe together. Don't forget to like this, comment on your thoughts, and subscribe for more incredible journeys through space and time. Thank you for your attention, and as always, keep looking up.